seen how we need these formulas, and they're going to be useful for us, useful to us when we're answering questions from week 10, because week 10 is very important. It's going to have a lot of questions. Let me just go and put everything you're going to put down here. And these things are just from week 10. Very, very important things that you're going to need. So what did we say? We said, remember that you should just get in and say, okay, I'm going to have a table, then I'm going to have a probability density function. I should know how to get the expectation when I have the table, and I should know how to get the variance as well. Okay, so how are we going to write it? Now we are going to write to say, okay, for expectation, we saw that it is just the sum of x times the probability of x. Okay, then here we saw that it is going to be the sum of x squared times probability of x, then minus the mean, which is expectation of x, and it is all squared. Okay, remember the mean is not summed. You subtract at the end after getting the sum. Then now we saw that for probability density function, it is going to be the integral of x times f of x with respect to x, and you're going to have the expectation. Then for here it is the integral of x squared times f of x with respect to x, but it's going to be again minus, okay, with respect to x, then it's going to be again minus the expectation of x all squared. Okay, now we say that, remember we say that this thing is also called the expectation of x squared, and this thing also, it is called the expectation of x squared. Okay, then one last thing which we talked about is how you are going to get probability for your probability density function. We saw how you're going to get probability that something is between a and b. Okay, we said it is going to be the integral from a to b of f of x itself. It's no longer x times f of x. It is f of x itself with respect to x. Then this is going to give us the probability. Okay, so there we go. Right, so this is going to be it. Now, when I have this, then I'm going to then just say next table. Okay, when I have this part is good, then the next table I'm going to say quantity, then rule. Okay, don't worry about the headline, the headings. The headings of the table are just something else, you know. But this is going to help us. This is the table of transformations. So say, you should say table of transformations. Okay. So now what is going to be the quantity? We're going to say when we have expectation, and it is going to be expectation of ax plus b. Then what happens? Okay, so this is just, you should know that the expectation or the mean is sensitive to everything, things that add and things that multiply. So this is just going to be we say a times the expectation of x, then plus b. Okay, so what are we going to do? Whatever something was doing to x, it is now going to do to expectation of x. So we can see that b was adding to x. Here it is going to add to the expectation. Then we can see that a was multiplying to x, and a is going to multiply to the expectation. That is what happens, okay? Then here we have again the variance of ax plus b. Now you should know that variance is not affected when you add or subtract. Variance is only affected when you multiply. And when you multiply, what must you do to get the new variance? To get it, you're going to square the thing which multiplies, which is a. So you square it, then you multiply it by the old variance, which is times variance of x. But b will never have an impact because it is just adding. So this is what you have, and you'd be done, okay? This is the second table. Now the last thing which you are going to just need to put is those things to do with the three common probability distributions, okay? And which one are we going to have? We start with the binomial. So we have the first one, which is going to be the binomial distribution. So what are we going to put for this binomial distribution? Well, we're going to put first that we just show that the quantity x follows binomial distribution. Then you need n and p. And n is the number of things. P is the probability that you'll be given in the question. Remember, for binomial, they'll give you the probability, then ask for something about... once they've given you the probability, they will now ask for something about it. Like, if they give you probability of an event, then they can now come and say, okay, so they've given you probability that something, okay, or a chance that some event was going to happen. Then they can now start to ask about the mean and whatever else. And that is just going to be a binomial distribution question, okay? That's just a binomial distribution. So you're going to say x follows binomial, then you put n and p. And n is the number of terms, then p is going to be the probability, which you'll be given in the question. It may be given as a percentage. Remember to change it to something. So this is going to be probability of success. And you must know that there's going to be Q, which is going to be 1 minus P. And this is just going to be the probability of failure. Now, what you must know is how you get the expectation, which is the mean. How do I get the mean when I have this? It is just going to be NP. And then how do I get the variance when I have this? It is just going to be NPQ. Then how do I get the probability? Okay, that X is equal to something. This is just going to be N choose X. Okay, this one you have to remember. You have to. It is a must to remember these things that I'm just giving you. The last three, which is for binomial. Then we have for Poisson distribution. Then we are going to have the last one, which is going to be normal distribution. So what is there to know? Okay, so here what are we going to do? So it'll be N choose X, right? Then P will be to the power of X again, the same X. Then now we have Q, and it'll be now to the power of N minus X. That is why we need the Q. We will need it in the formulas. Then we have the probability. So this is just going to be our probability, okay? And this small x will be a value, of course. Now we are going to have for Poisson. For Poisson, we are going to say again, X follows Poisson, but we'll just put lambda, which is going to be the average. You'll be given the average. Remember, for Poisson, you're going to be given the average, then they're going to ask for something. So here you're going to now know that to find the mean, if they ask for mean, it is just the same lambda. Then if to find variance, the variance of that thing is just the same lambda. And then the probability of X equal to X. This is now going to be very fun stuff, okay? This is going to be e to the negative lambda, then lambda to the x, then O over x factorial. So you should practice this, okay? If you practice it, you'll be good. E to the negative lambda, lambda to the x over x factorial, okay? And you'll be done. Now you can go to normal distribution. And normal distribution, we write it to say x follows normal distribution. Then what are we going to put? We're going to put the mean and we're going to put the variance. So it's going to be mean and variance. So what are we going to have now? Okay, the thing is, you're going to say, for me, I should be able to change x to z. And you'll be saying z is just going to be x minus this O over sigma. This gives us z. This is going to be how we get the value. It's x minus the mean O over the standard deviation. And we're going to have z. And this is going to be changing from x, which is just a normal variable, to z, which is the standard normal variable, so we can use the tables. And you'll be done. So here I've just fed you with the formulas that you're going to put. Remember, that when you have these formulas, it's going to be a walk in the park. Okay? This is going to be a walk in the park. So let's go ahead and let's go see what we got to do. And you'll be done.